Now that we've discussed some basics of one-to-one functions, let's go ahead and revisit some properties of inverse functions. So we'll start by assuming that we have a one-to-one function. If we don't have a one-to-one function, we're not going to have an inverse. So we'll go ahead and assume that f of x is a one-to-one function. And remember, the basic idea of inverse functions is that they switch the inputs and outputs. So for example, if you had something like f of 1 equals 7, then what that would mean about the inverse is f inverse of 7 is equal to 1. Let's take a look at what happens when you compose the inverse and the original function. So if I do f inverse of f of 1, remember what this means is we evaluate the inside first. So f of 1, that's equal to 7. So that's f inverse of 7. And now f inverse of 7 is 1. And what happens here is the 1 that I inputted to the composition turned out to be the output of the composition as well. This is not a coincidence. Let's imagine that for some different input, the output was 7. So for example, what if f of pi was equal to 7? Well, what that would mean for the inverse is that f inverse of 7 would not be equal to 1 anymore. It would be equal to pi. And now when you do f inverse of f of pi, well, f of pi is 7. So that means that we'll be doing f inverse of 7, and f inverse of 7 is pi. So the output here for the composition would be pi. In general, if we have that f of some x value is equal to a y value, well, that will mean that f of that y value is equal to x, and thus if we do f inverse of f of x, well, f of x is y, so then we would be doing f inverse of y, and so since f inverse of y is x, this will be equal to x. And what this says is that for all x, f inverse of f of x is equal to x. Also, what happens to be true is f of f inverse of x is equal to x for all x. So what we just talked about is if you have an inverse function, then you know that f inverse of f of x will be x, and f of f inverse of x will be x. It turns out that something even stronger is true. So let's suppose that we have two functions, f of x and g of x. Then if f of g of x equals x and g of f of x equals x for all x, then it turns out that g of x is actually the inverse of f of x. And when we say is in mathematics, that means equals. So it's a nice way to test if two functions are inverses of one another. So for example, our g of x equals x minus 2 over 3 and f of x equals 3x plus 2 inverses. What our previous discussion says is if you can determine that f of g of x and g of f of x is equal to x, then the answer is yes, they will be inverses. So let's see how that goes. So let's take a look at f of g of x. So in order to do this function composition, we first have to take a look at f. And everywhere we see an x, we have to replace it with what the inside function is. So 3 times g of x plus 2. Now we know what g of x is, so we can replace g of x with its definition. This is going to be 3 times x minus 2 all divided by 3 plus 2. And what happens here is the 3's cancel, and we have negative 2 and plus 2 canceling, and so we get that this is simply equal to x. Now I'll leave it to you, but it also turns out that g of f of x is equal to x. And so once you conclude that g of f of x is equal to x, the answer here would be yes. G of x is equal to f inverse of x. So as you see, this gives us a nice way to be able to determine if you have two functions and you want to know if they are inverses of one another, to be able to determine whether or not they are inverses of one another.